Hey everybody, welcome to a brief introduction to Scala. In the next 20 to 25 minutes, I'll be going over the history of Scala as a language, some of the things that make Scala a great language, and we'll focus on some of its standout features, so the things that really make it unique. Then we'll have a demo where I'll be using Scala to solve one of the Exercism exercises on the Scala track, and we'll finally list some of the resources that you can use to learn Scala. So I'm really excited about Scala and showing you the language. So let's get started. Scala was developed by Martin Odersky at the École Polytechnique Fédérale de Lausanne, or shortly EPFL. It's a functional language, strong and statically typed, and it's purposefully multi-paradigm. So this means that you can do functional programming in Scala, of course, but you can also do object-oriented programming. And the reason why this is so is because one of the goals of Scala was to make it easy for Java developers to get started with Scala. So Scala sort of resembles a lot of the features of Java. It does that in a slightly different way, though, because another goal of Scala was to address what were perceived as Java's shortcomings. So it has a very intimate relation with Java. It has great interop. It runs on the JVM, but it can also compile to JavaScript. And back in the days, it used to run on the .NET runtime too, but that has been abandoned in the early 2010s. An argument could be made that Scala was one of the more influential programming languages in that it helped popularize functional programming. So Twitter ran on Scala, Foursquare runs Scala, Duolingo runs Scala. It was one of the more widely adopted functional languages, and that really helped show that you could use a functional language in a production-like environment, even if you have huge companies with a large scale. Scala 3 was released fairly recently. It was a complete overhaul of Scala 2. A lot of lessons were learned, especially around the type system and how that could perhaps be simplified so that it would be easier to build in. And one of the things that Scala 3 also does is that it adds white space sensitivity, so you have significant indentation, and it has a ton of other features, but it's a complete overhaul. Let's discuss some of the reasons why Scala is such a great language. First of all, it has a very powerful type system. You have constructs like higher order types and implicit and traits and parameterized traits even. And with these very powerful features, you can write very expressive code, very powerful code, but it's still, you get all the benefits of a statically typed language. So you get all the guarantees that come with that. Of course, Scala also implements all of the staples of functional programming like lists and tuples and algebraic data types, and it has excellent type inference. So all in all, its powerful type system allows you to be very expressive while still getting a lot of guarantees, and the type system helps you write good code that doesn't have bugs. A second feature of Scala that is really great is its seamless blend of functional and object-oriented programming. It's completely natural in Scala to have functional code that uses objects. And it's this excellent feature of Scala that makes it so easy to interop with Java too. So Java is, of course, an object-oriented language, and it's completely natural to use anything that's been written in Java in your Scala code. And even in Scala itself, if you have a problem that's maybe better suited to an object-oriented approach, fine, Scala allows you to do that. Just write it in an object-oriented way. It doesn't feel jarring at all. And I think this is a very cool and maybe even underestimated feature of Scala, because it's not an easy thing to do, to blend these two worlds. Scala also has very good concurrency features, like a nice future system, which is a promises-like construct, and it has an active framework called Akka, and Akka is excellent for doing massively concurrent systems with actors in a familiar model that you might know of, Elixir and Erlang. Another thing that I really appreciate about Scala is that it's always at the forefront of functional programming language design. So a lot of its features are very new and cutting edge, and some of them you might not even see in other languages. So that makes it a very interesting language to work with. And the final thing that I want to mention is that they've been very they've been not afraid to make changes in Scala 3. So it's mostly backwards compatible, but they do have some breakages. And they have a migration guide that can help you with that, and there's automation there. But they still have found a way to improve upon the language while still keeping most of its core intact, even though it's actually overhauled quite significantly. So they have made some changes that are breaking, but most of it is non-breaking, while still getting a lot of new features and improving its very core. And I think it was handled very elegantly. Let's discuss some of Scala's standout features. The first standout feature is traits. And traits are somewhat similar to interfaces in object-oriented languages, where you define a name of the interface, and then you would have a list of methods that the type needs to implement in order to successfully say that, hey, they've implemented that interface. And you can use traits like that in Scala, but you can use them for more. So those functions, those methods that you define within the interface can also have a default implementation. And with this, you can actually have a class extend the trait, and you get the default implementation for free, which means that you can use traits as a sort of multiple inheritance almost. And this is a very powerful way to organize your code, as you can have these little bits of functionality in a trait, and then you can sort of inject them into your types. And this is also sometimes called mix-ins. So if you know by that name, it's somewhat similar. And it's a very powerful thing that Scala makes great use of. For example, in its standard library, it's full of traits. You see traits everywhere. And I highly encourage you to try out traits, because it's very, very cool to work with. And it gives you a very neat way of encapsulating bits of logic. The second standout feature that I'd like to discuss is implicits. And implicits mean a lot of different things. You have, and they mean different things between Scala 2 and Scala 3. So in Scala 2, you have implicit parameters. And implicit parameters are like parameters that the caller doesn't have to provide. So for example, if you have a function that does some logging, it takes the string to log. And the second thing is the logger that it logs to. You could have that logger parameter be implicit. And that means that the caller would just provide the first parameter, and then the implicit parameter would come from its context. And there are rules that specify where Scala looks for these implicit values, but you can use that logic without relying on passing in the actual logger, but you could do that somewhere else. And that makes it very, you can have like contextual code almost. It's very flexible, and it allows you to do tons of cool stuff with it. You can also use implicits to convert between types, or to extend types, even if you haven't even written those types yourself. For example, like the base library types. All these features are also all in Scala 3, but they're somewhat overhauled in that Scala 2 used implicit for all of these things, and Scala 3 has broken this up into different features. So you now have given and you have using, and they are sort of related, or even sometimes even the same thing as Scala 2 implicit, but they've been broken down to make it easier to reason about, and for the compiler to better be able to give you error messages if something is wrong. And it's a very cool feature too, and go try it out and see what you like. Let's look at some actual Scala code. What I'll be doing is to be solving the bank account exercise on the Exercism Scala track. The bank account exercise has you working with, well, bank accounts, and you have a balance, and you can increment it, you can get the balance. An account can be closed, and you can't increment or get the balance of a closed account, so we have to deal with state. And then to make things a little bit harder, we want to do this in a thread safe way, so that if we have multiple retrievals or deposits, then everything should still add up. So we shouldn't have missing money, which is clearly very bad. So this is the exercise that we will be solving. So let's get started. Let's examine what our stub implementation file looks like. The file contains two different types. So the first is a trait, and the trait is named bank account. As you might remember, the trait is something like an interface, but you could do more with it. For now, the trait that we will be using is used like an interface, in that it has just methods without an implementation. There are three methods within the trait. One is close account, the first one, takes no parameters and returns unit. And unit is the Scala equivalent of void, but it's an actual type. Then the second method is getBalance, which returns an option of int. And the option of int is a way of handling things that could go wrong. So if we get a balance of a closed account, that is not something that can actually be done. So what we do in that case, we return none. An option int value can be either none, which means that we couldn't execute it, or it can be sum with a value. So if the bank account is open, we return sum with the balance, and if it's closed, we return none. And this is a very functional way of dealing with errors. And we use a similar approach for increment balance. We have a single parameter, which is the amount to increment with, and we return an option int. And once again, if the account is closed, we return none. And if it isn't, we return the new balance wrapped in a sum value. Then the second thing that we have here is an object called bank. An object is different from a class. A class can be instantiated over and over again, so you can create instances of it. Whereas an object, there's only one. It's a singleton. So this is very familiar to people that have worked with static methods. So you can think of this open account method as being a static method on the bank class. One final thing to show is that these triple question marks here, this is actually compiling code. And what it will do if you try to run, if you call this method at runtime, you will get an error. This is not a compile time error, but a runtime error. And it can be a very helpful feature if you want to stub out your methods without actually implementing them and just get a general feel for your application. Let's start implementing our logic. The first thing that I'll be implementing is the open account method. It returns a bank account, but as bank account is our trait, we can't just return a trait because traits are not something that you can instantiate. So instead we have to create a class. We'll call it bank account impl, and it will implement our bank account trait. So to do so, we will have to implement all three methods from the trait, and we can start implementing them via just this triple question mark syntax. Then finally, what we do is we have to instantiate our newly defined type. So we're going to say new bank account impl, and let's run sbt test and see what the outcome is of that. And of course, we have failing tests. We also have one succeeding test. But yeah, so that's all good. We have a starting point now. So let's continue implementing things. So those question marks look very pretty, but they don't really do anything. So let's see if we can implement the close account functionality. So one thing that we can do is we could do var closed is of type Boolean, and initially it's false. And then what close account does is it set closed to true. And then we could have our closing of the account. So let's run this. And this doesn't actually change anything because we don't have any way of the test to figure out whether or not the account is closed. So you can only see if the account is closed by inferring that from the get balance or the increment balance result. If that returns none, that means it is closed. So we could have something like if closed, blah, blah, blah. But instead of that, why don't we take a different approach? And we will store the balance as an option int. And we'll use the fact that if the balance is none, the account is closed. And if it's sum with a value, it's opened. So we're going to say var balance. And then its type is an option of int. And by default, the account is open in our definition. And it starts out with the balance of 0. So returning the balance is now simply returning that variable that we just created. So get balance returns balance. And closing is just the matter of setting balance to none. And let's run our tests. See if we can get any to pass. And we now have 3 failing tests. So we are making progress. Let's start implementing the increment balance method. So we are defining some scope with curly braces. No, we're using Scala 2 because that's the current version that we have on Exercism. So we don't use the Scala 3 specific white space sensitive indentation. You can still use this syntax in Scala 3 too, so it is backwards compatible with this type of method. Within that method, we need to do 2 things. Either we have to detect whether or not the balance is currently none, which means that the account is closed, which means that we can't increment the balance and we have to return none. And the other way, we have an open account, so we have to get the current balance and then update the balance with the current balance plus what gets passed in as the increment parameter. So let's do that. The easiest way to work with an option value, or one of the ways that you can do that, is by pattern matching on it. So we can say, hey, balance match, and then there are different cases that we can do. There are 2 for some value, for an option value. Either it's none, and you can see here that I get nice IntelliSense, which is due to the fact that I've installed the VS Code plugin Scala Metals, which gives you all of the syntax highlighting and this type of IntelliSense for free. So we're going to say case none, and if it's none, we return none. We can also say, hey, case sum, and then get its current value. So this is an integer. What we then need to do, we need to update the current balance. So we're going to say balance is sum current plus the value that gets passed into the method. And then we'll return the balance. Let's run our tests. And we can see here that 1 test fails, but 4 succeeded. The failing test is one where the balance was incremented from multiple threads, and we'll get to that in a second. But for now, let's just see what this does. We pattern match on the balance. If it is none, the account is closed, so we can't increment the balance. If it is sum, we update the balance with the current value plus the increment, and then we'll return the balance. Let's try and fix that concurrency issue. The simplest way in which we can do that is by making sure that there is no possible way in which multiple threads can run the same code concurrently. And one thing that we can do is we can wrap this little updating of our balance in a synchronized block. And this basically ensures that there is no concurrent execution of the bit of code, which should solve our concurrency issue. But it doesn't. And that's actually because we forgot to add the balance itself in the synchronized block, because then that could be different. So let's run it again. And that's all fine. So now we have a nicely concurrent, safe way of incrementing our balance. It's a little bit verbose though. This whole pattern of doing none, none, sum, and then doing a little update is also something that you can do in a different way, which is using one of the option classes methods. So we're gonna say balance.map, and a map takes a function from an int to a new value b, and then the value that was returned is an option of b. But we're not gonna bother changing any of the values. We're gonna do current value, so that's what gets passed in, and what we return is current plus the increment. So this little function here is only called when the value is some value, not when it's none. So we have all this explicit pattern matching that's being done by the map method ourselves. So we're going to say balance is equal to this. So in the case of none, this would be just assigning none to the balance, and then otherwise we would use a new sum value with this as its value. So I'm going to return this. We're going to save ourselves a lot of code. We shouldn't be forgetting about still being synchronized. And then let's try and run this. And it still all passes. So that's great. We have done a little refactoring here. And then finally, we can do a little bit of refactoring still, as this map call uses a explicitly defined parameter, and then we'll use that parameter to and then increment. But there's a shorthand version that we can use. Namely, we can use the underscore if the lambda, the anonymous function that we were passing, only has a single parameter. We can just refer to it via the underscore value. So let's rerun it, and it should all still work, and it does. So with that, we have a fairly simple implementation. We have our balance stored as a mutable value. So you can see here var is mutable, and this shows you that we can work in Scala in an object-oriented way. So this is very object-oriented, where we have a class with states and methods, but also with using functional logic. So the option type is a very functional way to do things, as is this map method that takes in a higher order function that we use. And we have a nice combination of the functional paradigm and the object-oriented paradigm. Let's go over some of the resources that you can use to learn Scala. Of course, the Scala track on Exercism is a great way to improve your Scala skills. So we have over 90 exercises, and what I would highly recommend you doing is to take some exercises and try and solve them differently. So try a functional approach first, and then do an object-oriented approach and see how they differ and which one you like best. And I think the Scala tricks is an excellent way for you to especially work on that multi-paradigm feature of Scala. The official Scala book is a second resource that you can use, and it's like a series of mini tutorials that you can use to go over, and there's like one concept, there are some examples, some explanation, and if you take this this tour of the language, you basically have seen most of the bigger features, and you have a firm grasp of at least the basics of Scala. If you're new to functional programming, there is a course on Coursera taught by Martin Odersky, the person that actually developed Scala, and it's called Functional Programming Principles in Scala. And it teaches you the basics of functional programming using Scala as the language to learn it with. And I actually took this course myself, and I would highly recommend it to anybody. I had a ton of fun, even though some of it was really hard to initially get a grasp for. But Martin explained it really well. You get exercises, and I highly recommend doing it. And then finally, if you've dabbled in Scala a bit and you'd like to know more, I found the Neophyte's Guide to Scala is an excellent resource. So this assumes that you are familiar with the basics of Scala, but if you'd like to know more, they go into depth on some of the more advanced features of Scala, or maybe intermediate to advanced, I'd say. And they do a very excellent job of explaining them. So highly recommend the Neophyte's Guide to Scala.